Picture this, you're working on a project. You've asked all the right questions, applied structured thinking, and you're completely in sync with your stakeholders. You're off to a great start, but there's another step in the process, preparing the data correctly. This is where understanding the different types of data and data structures comes in. Knowing this lets you figure out what type of data is right for the question you're answering. Plus, you'll gain practical skills about how to extract, use, organize, and protect your data. Hey, my name's Hallie, and I'm an analytical lead at Google. I work with companies in the healthcare industry. I'm so excited to welcome you to this course. You've been building up your data analyst skills in lots of different ways so far. You've learned how to ask the right questions, define the problem, and present your analysis in a way that matches up with the needs of your stakeholders. In other words, you've learned how to tell a story using data. Now we'll learn more about the data that you'll need to tell the best story possible. But before we do that, I'd love to tell you my story. I use analytics to help healthcare companies develop digital marketing solutions that make their business and their brand stronger. My team and I find business and media opportunities based on the latest industry and data insights. I've been working in healthcare for about 5 years, and it's great. I really enjoy being able to use data to help spark change in such an important industry. As you'll discover in this course, data can be the main character in a very powerful story. I absolutely love using analysis to tell that story in a way that's compelling and informative. Here's a real-life example of how I've used data to tell a story. In my job, we analyze Medicare enrollment data over time and make connections to how people research Medicare plans on Google. As people 65 and older become more informed decision makers for their health, I use the data to learn if there's an increase in Medicare enrollments and what part Google searches play if there is an increase in demand. Now, it's very important that I make sure the data is relevant and valid. I also have to pay attention to questions around access and equity while maintaining the privacy of those conducting searches. The happy ending of my story is that the data in my findings is useful to medical professionals and their patients. There's so much useful data out there, and you're building the skills you'll need to find and use the right data in the best way. In this course, you'll continue sharpening those skills. So you've already heard a lot about the data analysis process steps: ask, prepare, process, analyze, share, and act. Now it's time to learn how to prepare the data. You'll learn to identify how data is generated and collected, and you'll explore different formats, types, and structures of data. We'll make sure you know how to choose and use data that'll help you understand and respond to a business problem. And because not all data fits each need, you'll learn how to analyze data for bias and credibility. We'll also explore what clean data means. But wait, there's more. You'll also get up close and personal with databases. We'll cover what they are and how analysts use them. You'll even get to extract your own data from a database using a couple of tools that you're already familiar with: spreadsheets and SQL. The key here is patience. Like anything worth doing, this will take time and practice, and I'll be with you every step of the way. Still with me? Great. The last few things we'll cover are the basics of data organization and the process of protecting your data. Data works best when it's organized, and if you're organizing your data, you'll want to protect it too. I'll show you how to do both and apply it to your own analysis. I'm so excited to help you write your own personal story as you continue exploring the world of data analytics. So let's do it. Healthcare is just a really fascinating place in the US. I find it's a really incredible industry to work in because it is so historically traditional. And healthcare companies, unlike other tech companies, just really have not used data to inform decisions. When I was in college, I had a professor who didn't want us to have textbooks because he just said the healthcare industry was changing so rapidly and it wouldn't make sense to have a textbook, which is just a static piece of text when things were just really evolving. And so I would say healthcare and data and the two together is a newer concept, using big data, using machine learning and artificial intelligence to help the healthcare industry. I started analyzing large sums of patient data. That was the first time I had really worked with such huge data sets. And I found it really fascinating that we can take all of these data sets and synthesize them and allow us to really deliver some cool insights and trends to our hospital systems. That was the first time I started thinking about data analysis, data analytics as a possible career for me. And so that's really what brought me to this analytical lead role at Google, where I could take that knowledge and that skill set of analyzing data sets and do that on a daily basis, so that really every conversation I was having with the client was a data-informed conversation. I work within the healthcare vertical. So we have companies who market on our platforms like Google Search and YouTube. And so we help them understand the healthcare industry so that they can better market to the audience that they're trying to reach. Whether you're a healthcare insurer or you're a healthcare provider, maybe a hospital system, they all have different needs on how they want to reach their audience using Google's platforms. So we help them optimize their marketing spend, but we also do a lot of research in the healthcare industry, some user research, some understanding of how users are really just searching on Google to give them a sense of what's really happening in the industry and how they can market effectively. I would say that my technical skills with data analytics came with time. And the most important skill I found, which has also come with time and grown with me, is just the creativity side of data analysis. I mean, you can really learn a lot of the SQL skills and R, and I know some of that is within the course. But really the creativity side is something that just comes with experience. So when you're looking at a data set, you might look at it one way and analyze it one way, and then have someone else look at it or look at it a week later, and then all of a sudden the trend that you're seeing is completely different. So you have to take a lot of these pieces of information, these nuggets I like to call them, and just piece together a really nice narrative using data. And so that skill set is something I learned when I was working in consulting, and I've taken that to Google and really been able to polish a lot of those skills and some of the more technical skills. So technical and the creative side are what I've grown to love. My name is Hallie. I'm an analytical lead at Google, working specifically in the healthcare vertical. Right now, data is being generated all around the world, and we're talking tons of data. Every minute of every day, millions of texts and hundreds of millions of emails are sent. On top of that, millions of online searches are made and videos viewed. And those numbers are only growing. That's a lot of data. So let's learn more about how it's made and used. In this video, we'll talk about the ways that data can be generated and how industries collect data themselves. Every piece of information is data, and all that data is usually generated as a result of our activity in the world. These days, we spend a lot of time online. With social media and mobile devices, millions and millions of people are adding to the huge amount of data out there, each and every day. Think about it like this. Every digital photo online is one piece of data. And every photo itself holds even more data, from the number of pixels to the colors contained in each of those pixels. But that's not the only way data is made. We can also generate data by collecting information. This kind of data generation and collection comes with a few more things to think about. It needs to be done with consideration to ethics so that we maintain people's rights and privacy. We'll learn more about that later on. For now, let's check out a real-world example. The United States Census Bureau uses forms to collect data about the country's population. This data is used for a number of reasons, like funding for schools, hospitals, and fire departments. The Bureau also collects information about things like U.S. businesses, creating their own data in the process. The great thing about this is that others can then use the data for their own needs, including analysis. The annual business survey is used to figure out the needs of businesses and how to provide them with resources to help them succeed. I actually generate data in the analytics I do for the healthcare industry. We run a lot of surveys to learn how patients feel about certain things related to their healthcare. For example, one survey asked how patients feel about telemedicine versus in-person doctor visits. The data we collected helped the companies we work with improve the care that their patients receive. Survey data is just one example. There's all kinds of data being generated all the time, and there's lots of different ways to collect it. Even something as simple as an interview can help someone collect data. Imagine you're in a job interview. To impress the hiring manager, you'll want to share information about yourself. The hiring manager collects that data and analyzes it to help them decide whether to hire you or not. But it goes both ways. You could also collect your own data about the company to help you decide if the company is a good fit for you. Or you can use the data you collect to come up with thoughtful questions to ask the interviewer. Scientists also generate data. They use a lot of observations in their work. For example, they might collect data by studying animal behavior or looking at bacteria under a microscope. Earlier, we talked about the forms that the U.S. Census Bureau uses to collect data. Forms, questionnaires, and surveys are commonly used ways to collect and generate data. One thing to note, data that's generated online doesn't always happen directly. Have you ever wondered why some online ads seem to make really accurate suggestions? Or how some websites remember your preferences? This is done using cookies, which are small files stored on computers that contain information about users. Cookies can help inform advertisers about your personal interests and habits based on your online surfing without personally identifying you. As a real-world analyst, you'll have all kinds of data right at your fingertips, and lots of it too. Knowing how it's been generated can help add context to the data, and knowing how to collect it can make the data analysis process more efficient. Coming up, you'll learn how to decide what data to collect for your analysis, so stay tuned. Welcome back. We've talked a lot about all the data out there in the world, but as a data analyst, you'll need to decide what kind of data to collect and use for every project. And with a nearly endless amount of data out there, this can be quite a bit of a data dilemma. But there's good news. In this video, you'll learn which factors to consider when collecting data. Usually, you'll have a head start in figuring out the right data for the job because the data you need will be given to you, or your business task or problem will narrow down your choices. So let's start with a question like, what's causing increased rush hour traffic in your city? First, you need to know how the data will be collected. You might use observations of traffic patterns to count the number of cars on city streets during particular times. You notice that cars are getting backed up on a specific street. That brings us to data sources. In our traffic example, your observations would be first-party data. This is data collected by an individual or group using their own resources. Collecting first-party data is typically the preferred method because you know exactly where it came from. You might also have second-party data, which is data collected by a group directly from its audience and then sold. So in our example, if you aren't able to collect your own data, you might buy it from an organization that's led traffic pattern studies in your city. This data didn't start with you, but it's still reliable because it came from a source that has experience with traffic analysis. The same can't always be said about third-party data, or data collected from outside sources who did not collect it directly. This data might have come from a number of different sources before you investigated it, so it might not be as reliable. But that doesn't mean it can't be useful. You'll just want to make sure you check it for accuracy, bias, and credibility. Actually, no matter what kind of data you use, it needs to be inspected for accuracy and trustworthiness. We'll learn more about that process later. For now, just remember that the data you choose should apply to your needs and it must be approved for use. As a data analyst, it's your job to decide what data to use. And that means choosing the data that can help you find answers and solve problems, and not getting distracted by other data. In our traffic example, financial data probably wouldn't be that helpful, but existing data about high-volume traffic times would be. Okay, now let's talk about how much data to collect. In data analytics, a population refers to all possible data values in a certain data set. So if you're analyzing data about car traffic in a city, your population would be all of the cars in that area. But collecting data from the entire population can be pretty challenging. That's why a sample can be useful. A sample is a part of a population that is representative of the population. You might collect a data sample about one spot in the city and analyze the traffic there. Or you might pull a random sample from all existing data in the population. How you choose your sample will depend on your project. As you collect data, you'll also want to make sure you select the right data type. For traffic data, an appropriate data type could be the dates of traffic records stored in a date format. The dates can help you figure what days of the week there is likely to be a high volume of traffic in the future. We'll explore this topic in more detail soon. Finally, you need to determine the time frame for data collection. In our example, if you needed an answer immediately, you'd have to use historical data, which is data that already exists. But let's say you needed to track traffic patterns over a long period of time. That might affect the other decisions you make during data collection. And now you know more about the different data collection considerations you'll use as a data analyst. And because of that, you'll be able to find the right data when you start collecting it yourself. There's still more to learn about data collection, so stay tuned. I don't know about you, but when I'm choosing a movie to watch, I sometimes get stuck between a couple of choices. If I'm in the mood for excitement or suspense, I might go for a thriller. But if I need a good laugh, I'll choose a comedy. If I really can't decide between two movies, I might even use some of my data analysis skills to compare and contrast them. Come to think of it, there really needs to be more movies about data analysts. I'd watch that. But since we can't watch a movie about data, at least not yet, we'll do the next best thing. Watch data about movies. We're going to take a look at this spreadsheet with movie data. We know we can compare different movies and movie genres. Turns out you can do the same with data and data formats. Let's use our movie data spreadsheet to understand how that works. We'll start with quantitative and qualitative data. If we check out column A, we'll find titles of the movies. This is qualitative data because it can't be counted, measured, or easily expressed using numbers. Qualitative data is usually listed as a name, category, or description. In our spreadsheet, the movie titles and cast members are qualitative data. Next up is quantitative data, which can be measured or counted and then expressed as a number. This is data with a certain quantity, amount, or range. In our spreadsheet here, the last two columns show the movie's budget and box office revenue. The data in these columns is listed in dollars, which can be counted, so we know that data is quantitative. We can go even deeper into quantitative data and break it down into discrete or continuous data. Let's check out discrete data first. This is data that's counted and has a limited number of values. Going back to our spreadsheet, we'll find each movie's budget and box office returns in columns M and N. These are both examples of discrete data. They can be counted and have a limited number of values. For example, the amount of money a movie makes can only be represented with exactly 2 digits after the decimal to represent cents. There can't be anything between 1 and 2 cents. Continuous data can be measured using a timer, and its value can be shown as a decimal with several places. So let's imagine a movie about data analysts that I'm definitely going to star in someday. You could express that movie's runtime as 110.0356 minutes. You could even add fractional data after the decimal point if you needed to. There's also nominal and ordinal data. Nominal data is a type of qualitative data that's categorized without a set order. In other words, this kind of data doesn't have a sequence. Here's a quick example. Let's say you're collecting data about movies. You ask people if they've watched a given movie. Their responses would be in the form of nominal data. They could respond yes, no, or not sure. These choices don't have a particular order. Ordinal data, on the other hand, is a type of qualitative data with a set order or scale. If you asked a group of people to rank a movie from 1 to 5, some might rank it as a 2, others a 4, and so on. These rankings are in order of how much each person liked the movie. Now let's talk about internal data, which is data that lives within a company's own systems. For example, if a movie studio had compiled all of the data in the spreadsheet using only their own collection methods, then it would be their internal data. The great thing about internal data is that it's usually more reliable and easier to collect. But in this spreadsheet, it's more likely that the movie studio had to use data owned or shared by other studios and sources because it includes movies they didn't make. That means they'd be collecting external data. External data is, you guessed it, data that lives and is generated outside of an organization. External data becomes particularly valuable when your analysis depends on as many sources as possible. A great thing about this data is that it's structured. Structured data is data that's organized in a certain format, such as rows and columns. Spreadsheets and relational databases are two examples of software that can store data in a structured way. You might remember our earlier exploration of structured thinking, which helps you add a framework to a problem so that you can solve it in an organized and logical manner. You can think of structured data in the same way. Having a framework for the data makes the data easily searchable and more analysis ready. As a data analyst, you'll work with a lot of structured data, which will usually be in the form of a table, spreadsheet, or relational database. But sometimes you'll come across unstructured data. This is data that is not organized in any easily identifiable manner. Audio and video files are examples of unstructured data because there's no clear way to identify or organize their content. Unstructured data might have internal structure, but the data doesn't fit neatly in rows and columns like structured data. And there you have it. Hopefully you're now more familiar with data formats and how you might use them in your work. And in just a bit, you'll continue to explore structured data and learn even more about the data you'll use most often as an analyst, coming soon to a screen near you. Hi, great to see you again. Earlier, we compared some data formats, including structured and unstructured data. Most of the data being generated right now is actually unstructured. Audio files, video files, emails, photos, and social media are all examples of unstructured data. These can be harder to analyze in their unstructured format. But here's the good news. You'll be working with structured data most of the time. For example, if you need to analyze data about the unstructured data in emails, photos, and social media sites, it'll most likely be structured for analysis before you even get to it. Because of that, I want to explore structured data a bit more. As a quick refresher, structured data is data organized in a format like rows and columns, but there's definitely more to it than that. Structured data works nicely within a data model, which is a model that is used for organizing data elements and how they relate to one another. What are data elements? They're pieces of information, such as people's names, account numbers, and addresses. Data models help to keep data consistent and provide a map of how data is organized. This makes it easier for analysts and other stakeholders to make sense of their data and use it for business purposes. In addition to working well within data models, structured data is also useful for databases. This makes it easy for analysts to enter, query, and analyze the data whenever they need to. This also helps make data visualization pretty easy because structured data can be applied directly to charts, graphs, heat maps, dashboards, and most other visual representations of data. All right, so now we know that spreadsheets and databases that store datasets are widely used sources of structured data. After you explore some other data structures, you'll check out more data types using a spreadsheet. The adventure continues. By now you've learned a lot about data. From generated data to collected data to data formats, it's good to know as much as you can about the data you'll use for analysis. In this video, we'll talk about another way you can describe data, the data type. A data type is a specific kind of data attribute that tells what kind of value the data is. In other words, a data type tells you what kind of data you're working with. Data types can be different depending on the query language you're using. For example, SQL allows for different data types depending on which database you're using. For now, though, let's focus on the data types that you'll use in spreadsheets. To help us out, we'll use a spreadsheet that's already filled with data. We'll call it Worldwide Interest in Suites through Google searches. Now, a data type in a spreadsheet can be one of three things: a number, a text, or string, or a Boolean. You might find spreadsheet programs that classify them a bit differently or include other types. But these value types cover just about any data you'll find in spreadsheets. We'll look at all of these in just a bit. Looking at columns B, D, and F, we find number data types. Each number represents the search interest for the terms cupcakes, ice cream, and candy for a specific week. The closer a number is to 100, the more popular that search term was during that week. 100 represents peak popularity. Keep in mind that, in this case, 100 is a relative value, not the actual number of searches. It represents the maximum number of searches during a certain time. Think of it like a percentage on a test. All other searches are then also valued out of 100. You might notice this in other data sets as well. Gold star for 100. If you needed to, you could change the numbers into percents or other formats like currency. These are all examples of number data types. In column H, the data shows the most popular treat for each week, based on the search data. So as we'll find in cell H4, for the week beginning July 28, 2019, the most popular treat was ice cream. This is an example of a text data type, or a string data type, which is a sequence of characters and punctuation that contains textual information. In this example, that information would be the treats and people's names. These can also include numbers like phone numbers or numbers and street addresses, but these numbers wouldn't be used for calculations. So in this case, they're treated like text, not numbers. In columns C, E, and G, it seems like we've got some text. But the text here isn't a text or string data type. Instead, it's a Boolean data type. A Boolean data type is a data type with only two possible values, true or false. Columns C, E, and G show Boolean data for whether the search interest for each week is at least 50 out of 100. Here's how it works. To get this data, we've created a formula that calculates whether the search interest data in columns B, D, and F is 50 or greater. In cell B4, the search interest is 14. So in cell C4, we find the word false, because for this week of data, the search interest is less than 50. So for each cell in columns C, E, and G, the only two possible values are true or false. We could change the formula so other words appear in these cells instead, but it's still Boolean data. You'll get a chance to read more about the Boolean data type soon. Let's talk about a common issue that people encounter in spreadsheets: mistaking data types with cell values. For example, in cell B57, we can create a formula to calculate data in other cells. This will give us the average of the search interest in cupcakes across all weeks in the dataset, which is about 15. The formula works because we calculated using a numbered data type, but if we tried it with a text or string data type, like the data in column C, we'd get an error. Error values usually happen if a mistake is made in entering the values in the cells. So the more you know your data types and which ones to use, the less errors you'll run into. There you have it, a data type for everyone. And we're not done yet. Coming up, we'll go deeper into the relationship between data types, fields, and values. See you soon. Here's a riddle for you. What do a music playlist, a calendar agenda, and an email inbox have in common? I'll give you a hint. It's not a weekly jam session. The answer is they're all arranged in tables. Go ahead and check out your email inbox or a favorite playlist, or look at your calendar agenda. There's tables in every one. A data table, or tabular data, has a very simple structure. It's arranged in rows and columns. You can call the rows records and the columns fields. They basically mean the same thing, but records and fields can be used for any kind of data table, while rows and columns are usually reserved for spreadsheets. When talking about structured databases, people in data analytics usually go with records and fields. Sometimes, a field can also refer to a single piece of data, like the value in a cell. In any case, you'll hear both versions of these terms used throughout this program and your job. Let's go back to our playlist example. We'll use the new terms we just introduced. So each song is a record. Each record has the same fields as the other records, in the same order. In other words, the playlist has the same information about each song. Each song characteristic, like the title and the artist, is a field. Each separate field has the same data type, but different fields can have different types. Let me show you what I mean. For the song list, the song titles are a text or string type, while the song's length could be a number type if you're using it for calculations, or it could be a date and time type. The column for favorites is Boolean, since it has two possible values, favorite or not favorite. We can view spreadsheets in the same way. The records in a spreadsheet might be about all sorts of things, clients, products, invoices, or really anything else. Each record has several fields, which reveal more about the clients, products, or invoices. The value in every cell contains a specific piece of data, like the address of a client or the dollar amount of an invoice. As a data analyst, lots of data will come your way, and records, fields, and values in data tables will help you navigate analysis. Understanding the structures of the tables you're working with is a part of that. And hopefully, while you're working hard on your analysis in those tables, you can have a little fun with a different data table, the one with your favorite playlist. You probably use the words wide and long all the time. You might use wide to describe the size of something from side to side, like a wide river, but a river can also travel great distances, so you might call it long as well. Wait. Before you stop the video, I promise you didn't accidentally click in the wrong course. I'm not here to teach you words you already know, but the words wide and long can be used to describe data too. So I am here to help you understand wide data and long data. So far, you've dealt with data arranged mostly in a wide format. With wide data, every data subject has a single row with multiple columns to hold the values of various attributes of the subject. Here's some wide data in a spreadsheet. You might remember we discussed this data about the population of Latin and Caribbean countries earlier. For this data set, each row provides all of the population information about one country. Each column shows the population for a different year. Wide data lets you easily identify and quickly compare different columns. In our example, the data is arranged alphabetically by country, so you can compare the annual populations of Antigua and Barbuda, Aruba, and the Bahamas by just checking out the values in each column. The wide data format also makes it easy to find and compare the country's populations at different periods of time. For example, by sorting the data, we discover that Brazil had the highest population of all countries in 2010. And the British Virgin Islands had the lowest population of all countries in 2013. Okay, now let's explore this data in a long format. Here, the data is no longer organized into columns by year. All the years are now in one column with each country, like Argentina appearing in multiple rows, one for each year of data. This is how long data usually looks. Long data is data in which each row is one time point per subject, so each subject will have data in multiple rows. Our spreadsheet is formatted to show each year of population data. Here we see Antigua and Barbuda first. Long data is a great format for storing and organizing data when there's multiple variables for each subject at each time point that we want to observe. With this long data format, we can store and analyze all of this data using fewer columns. Plus, if we added a new variable, like the average age of a population, we'd only need one more column. If we'd use a wide data format instead, we would have needed 10 more columns, one for each year. The long data format keeps everything nice and compact. If you're wondering which format you should use, the simple answer is, it depends. Sometimes you'll have to transform wide data into a long data format, or other times vice versa. You'll probably work with both formats in your job, and you'll definitely revisit both formats again later in this program. That reminds me, earlier we defined data as a collection of facts. As you've discovered over the last few videos, that collection of facts can take on lots of different formats, structures, types, and more. Learning about all of the ways that data can be presented will be a big help to you throughout the data analysis process. The more you work with data in all its forms, the quicker you'll start to recognize which data to use and when to use it. And in just a bit, you'll use all that data stored in your brain to help you take an assessment. After that, you'll learn how to identify and avoid bias in data and how to embrace credibility, integrity, and ethics. The data adventure moves forward. I'm so glad you're moving with it. Welcome back. In an earlier course, we talked about how to prepare data in a way that helps you tell a meaningful story. Now let's find out what comes next. Like all good tales, your data story will be filled with characters, questions, challenges, conflict, and hopefully a resolution. The trick is to avoid the conflict, overcome the challenges, and answer the questions. That's what this course is all about. Here's how we'll do it. First, you'll learn how to analyze data for bias and credibility. This is very important because even the most sound data can be skewed or misinterpreted. Then we'll learn about the importance of being good and bad. Yep, just like when we were kids. But in this case, we'll be exploring good data sources and learning how to steer clear of their nemesis, bad data. After that, we'll learn more about the world of data ethics, privacy, and access. As more and more data becomes available and the algorithms we create to use this data become more complex and sophisticated, new issues keep popping up. We need to ask questions like, who owns all this data? How much control do we have over the privacy of data? Can we use and reuse data however we want to? As a data analyst, it's important to understand data ethics and privacy because in your work, you'll make a lot of judgment calls on the correct use and application of data. I'm excited to walk you through some of the questions, answers, risks, and rewards involved. Let's open up the first chapter of this data story in our next video. Let's kick things off by traveling back in time. Well, in our minds at least. My real time machine's in the shop. Imagine you're back in middle school and you've entered a project for the science fair. You worked hard for weeks perfecting every element and they're about to announce the winners. You close your eyes, take a deep breath, and you hear them call your name. For second place. Bummer. You really wanted that first place trophy, but hey, you'll take the ribbon for recognition. The next day, you learn the judge was the winner's uncle. How is that fair? Can he really be expected to choose a winner fairly when his own family member is one of the contestants? He's probably biased. Well, maybe his niece deserved to win, and maybe not. But the point is, it's very easy to make a case for bias in that scenario. Now, this is a super simple example, but the truth is, we run into bias all the time in everyday life. Our brains are biologically designed to streamline thinking and make quick judgments. Bias has evolved to become a preference in favor of or against a person, group of people, or thing. And it can be conscious or subconscious. The good news is, once we know and accept that we have bias, we can start to recognize our own patterns of thinking and learn how to manage it. It's important to know that bias can also find its way into the world of data. Data bias is a type of error that systematically skews results in a certain direction. Maybe the questions on a survey had a particular slant to influence answers, or maybe the sample group wasn't truly representative of the population being studied. For example, if you're going to take the median age of the US patient population with health insurance, you wouldn't just use a sample of Medicare patients who are 65 and older. Bias can also happen if a sample group lacks inclusivity. For example, people with disabilities tend to be underidentified, underrepresented, or excluded in mainstream health research. The way you collect data can also bias a dataset. For example, if you give people only a short time to answer questions, their responses will be rushed. When we're rushed, we make more mistakes, which can affect the quality of our data and create biased outcomes. As a data analyst, you have to think about bias and fairness from the moment you start collecting data to the time you present your conclusions. After all, those conclusions can have serious implications. Think about this. It's been acknowledged that clinical studies of heart health tend to include a lot more men than women. This has led to women failing to recognize symptoms and ultimately having their heart conditions go undetected and untreated. That's just one way bias can have a very real impact. While we've come a long way in recognizing bias, it's still led to you losing out to the judge's niece at that science competition. And it's still influencing business decisions, healthcare choices and access, governmental action, and more. So we've still got work to do. Coming up, we'll show you how to identify bias in the data itself and explore some scenarios when you may actually benefit from it. Hello again. So far, we've learned that the biases we have as people can end up creating biased data. We're biased when we have preferences based on our own preconceived or even subconscious notions. When data is biased, it can systematically skew results in certain direction, making them unreliable. We covered this earlier using sampling bias as an example. Sampling bias is when a sample isn't representative of the population as a whole. You can avoid this by making sure the sample is chosen at random so that all parts of the population have an equal chance of being chosen. If you don't use random sampling during data collection, you end up favoring one outcome. Here's a simple way to look at it. Let's say there's 50 students in one class, and you want to know if the majority prefers warm weather or cold weather. You decide to survey 10 female students and determine that the class prefers warm weather. But wait, there's some bias here. Your survey wasn't a fair representation of the entire class because it didn't include males and non-binary students. If you'd used a more randomized sample of the population that included all genders, you'd have an unbiased sample. Unbiased sampling is a sample that's representative of the population being measured. Another great way to discover if you're working with unbiased data is to bring the results to life with visualizations. In the class example we just covered, you could visualize the number of male and female students in the class overall with a bar chart. You could then compare that to a similar bar chart showing the number of male and female students you surveyed. This will help you easily identify any big issues with your sample. As a general rule, it's our goal as data analysts to avoid bias. But believe it or not, there are actually situations where a biased sample can come in handy. If you're trying to get more actionable data, bias can help you narrow your focus. For example, if you were trying to predict and plan a company's budget for the coming year, you'd probably check out last year's sales. You're technically using biased data because it's not taking into account other variables, but it is helping you narrow your focus. Okay, now that we know what bias looks like from a sampling perspective, let's explore some other types of bias and how to recognize them. Coming up next. I may be biased, but I think learning about the good and the bad traits of data is pretty fascinating. Next up, we'll discover that there's lots of different types of data bias besides sampling bias, which we covered earlier. As a quick refresher, sampling bias is when a sample isn't representative of the population as a whole. For example, if you're doing research on commuters and only survey people walking by on the sidewalk, you'll miss out on input from people who ride bicycles, drive, or take the subway. You need all sides of the story to avoid sampling bias. In this video, we'll explore 3 more types of data bias: observer bias, interpretation bias, and confirmation bias, and we'll learn how to avoid them. Let's start with observer bias, which is sometimes referred to as experimenter bias or research bias. Basically, it's the tendency for different people to observe things differently. You might remember earlier we learned that scientists use observations a lot in their work, like when they're looking at bacteria under a microscope to gather data. Well, 2 scientists looking into the same microscope might see different things. That's observer bias. Another time observer bias might happen is during manual blood pressure readings. Because the pressure meter is so sensitive, healthcare workers often get pretty different results. Usually, they'll just round up to the nearest whole number to compensate for the margin of error. But if doctors consistently round up or down the blood pressure readings on their patients, health conditions may be missed and any studies involving their patients wouldn't have precise and accurate data. Another common type of data bias is interpretation bias, the tendency to always interpret ambiguous situations in a positive or negative way. Here's an example. Let's say you're having lunch with a colleague when you get a voicemail from your boss asking you to call her back. You put the phone down in a huff, certain that she's angry and you're on the hot seat for something. But when you play the message for your friend, he doesn't hear anger at all. He actually thinks she sounds calm and straightforward. Interpretation bias can lead to two people seeing or hearing the exact same thing and interpreting it in a variety of different ways because they have different backgrounds and experiences. Your history with your boss made you interpret the call one way, while your friend interpreted it in another way because they're strangers. Add these interpretations to a data analysis, and you can get biased results. The last type of bias we'll cover reminds me of the saying, people see what they want to see. That pretty much sums up confirmation bias in a nutshell. Confirmation bias is the tendency to search for or interpret information in a way that confirms pre-existing beliefs. Someone might be so eager to confirm a gut feeling that they only notice things that support it, ignoring all other signals. This happens all the time in everyday life. We might get our news from a certain website because the writers share our beliefs, or we socialize with people because we know that they hold similar views. After all, conflicting viewpoints might cause us to question our worldview, which can lead us to changing our whole belief system. And let's face it, change is tough, but you know what's even tougher? Doing good work when you have bad data. So it's important to keep bias out of it. The 4 types of data bias we covered, sampling bias, observer bias, interpretation bias, and confirmation bias, are all unique, but they do have one thing in common. They each affect the way we collect and make sense of the data. Unfortunately, they're also just a small sample, pun intended, of the types of bias you may encounter in your career as a data analyst. But the good news is, once you know a few, you'll find yourself constantly on guard for bias in any form. It's also important to remember that no matter what kind of data you use, all of it needs to be inspected for accuracy and trustworthiness. We'll talk more about that soon when we start exploring bad data. Bye for now. Hey, what's good? No, really. I want to know, what is good? Let me put it this way. If I asked you to name a good song, I might not like it. That's because good is subjective. What I think is good and what you think is good might be different. So what about good data sources? Are those subjective too? In some ways they are, but luckily there's some best practices to follow that'll help you measure the reliability of data sets before you use them. That's what we'll discuss in this video. I think we can all agree that we all want good data. The more high-quality data we have, the more confidence we can have in our decisions. So let's learn how we can go about finding and identifying good data sources. First things first, we need to learn how to identify them, a process I like to call ROCC. R-O-C-C-C. Okay, I just made that up, but I think acronyms are a really great way to help new information to stick in the brain. Kicking things off, R for reliable. Like a good friend, good data sources are reliable. With this kind of data, you can trust that you're getting accurate, complete, and unbiased information that's been vetted and proven fit for use. Okay, on to O. O is for original. There's a good chance you'll discover data through a second or third-party source. To make sure you're dealing with good data, be sure to validate it with the original source. Time for the first C. C is for comprehensive. The best data sources contain all critical information needed to answer the question or find the solution. Think about it like this. You wouldn't want to work for a company just because you found one great online review about it. You'd research every aspect of the organization to make sure it was the right fit. It's important to do the same for your data analysis. The next C is for current. The usefulness of data decreases as time passes. If you wanted to invite all current clients to a business event, you wouldn't use a 10-year-old client list. The same goes for data. The best data sources are current and relevant to the task at hand. The last C is for cited. If you've ever told a friend where you heard that a new movie sequel was in the works, you've cited a source. Citing makes the information you're providing more credible. So when you're choosing a data source, think about 3 things. Who created the data set? Is it part of a credible organization? And when was the data last refreshed? If you have original data from a reliable organization and it's comprehensive, current, and cited, it rocks. There's lots of places that are known for having good data. Your best bet is to go with vetted public data sets, academic papers, financial data, and governmental agency data. Now that you know how to spot the good data, which rocks, you're ready to learn about the mountain of bad data and how to avoid it. Let's get moving. Welcome back. Last time we met, we learned how to identify and find good data sources, a process I ended up coining ROC. We found that if the dataset is reliable, original, comprehensive, current, and cited, it rocks. Or more seriously, it's good. Hopefully, this is refreshing your memory. Now it's time to pull from what we learned about good data and apply it to today's lesson, bad data sources that don't rock. They're not reliable, original, comprehensive, current, or cited. Even worse, they could be flat out wrong or filled with human error. We'll start again with R. R is for not reliable. Bad data can't be trusted because it's inaccurate, incomplete, or biased. This could be data that has sample selection bias because it doesn't reflect the overall population, or it could be data visualizations and graphs that are just misleading. Check out these two bar graphs, for example. The one on the left uses a y-axis starting point of 3.14%, and the one on the right uses 0. This makes it seem like interest rates have skyrocketed over a 4-year period when they've actually remained pretty flat. Okay, on to O. O is for not original. If you can't locate the original data source and you're just relying on second or third-party information, that can signal you may need to be extra careful in understanding your data. Now, C is for not comprehensive. Bad data sources are missing important information needed to answer the question or find the solution. What's worse, they may contain human error too. The next C is for not current. Bad data sources are out of date and irrelevant. Many respected sources refresh their data regularly, giving you confidence that it's the most current info available. For example, you can always trust data.gov, which is home to the US government's open data. The last C is for not cited. If your source hasn't been cited or vetted, it's a no-go. So to sum up, good data should be original data from a reliable organization, comprehensive, current, and cited. It should rock. Otherwise, it's bad data. If you need a great, reliable data source, check out the US Census Bureau, which regularly updates their information. It's important for data analysts to understand and keep an eye out for bad data because it can have serious and lasting impacts. Whether it's an incorrect conclusion leading to one bad business decision, or inaccurate information causing processes to fail and putting populations at risk, every good solution is found by avoiding bad data. For good data, stick with vetted public data sets, academic papers, financial data, and governmental agency data. And with that, we've come to the end of our adventure with bias and credibility. After a few more exercises, you'll be ready for what lies ahead. I look forward to your progress.
Welcome to Quick Labs. Now it's time to get hands-on practice on a lot of the amazing data analyst concepts that you've learned so far. Here's where you get to prove that you've learned some great technologies, and then you'll get credit for it back inside of Coursera. But before you jump right in, let me just give you a quick walkthrough of what a Quick Lab is, and then we'll get started. First and foremost, in the upper left-hand corner, you notice a gigantic tempting button called Start Lab in green. I want to go ahead and start that. Click this box that says, I'm not a robot. Select a few of the different items here for captures. You can see this is the hardest part of the lab, is trying to actually get through the anti-robot technology that they have here. Now, a couple things happen in the background. As author of these labs, this is some of our best work that we're getting you hands-on practice for. And what you're going to do next is just make sure that that timer starts counting down, because then that's going to give you the account logins that you need to practice the work inside the lab. Now, here's what you're going to do. There's going to be a gigantic big button that says Open Google Cloud Console. I want you to go ahead and click on that. And now you have 3 browser tab windows open, or 100 if you're like me. And in the second browser, this is your Quick Labs login. All the way under username, what I want you to do is copy that username. And here's the number one mistake that I've seen students make. When you're back into Google, everyone sees this Google sign-in screen here, and they immediately start typing in their personal Gmail address. You don't want to be charged for any of the resources that you're going to be using. That's why we're providing you with this Quick Labs account yourself. And all I'm going to do is paste in the email that's been given to me by the Quick Lab for use for an hour. and then click Next. And then I'm going to go ahead and grab the password, paste that in here. And then you're going to see a bunch of terms and conditions because this is a brand new account. Scroll through the terms and conditions, read them at your leisure, click Accept. And as you work through the terms of service here, eventually you'll land on the homepage for Google Cloud. Scroll down, read the terms of service, accept terms of service. All the steps that I'm walking you through right now are also available inside of the lab written instructions as well. So once you've gotten that out of the way, let's take a look at what this particular quick lab is going to teach you. At a high level, I'm not going to do the lab for you, but don't worry, it's step by step. You'll have a blast doing it. And you have way more than enough time you need in this timer before your lab timer runs out. Generally, as lab authors, we try to double the budget of allowed time, so don't worry about lab timeouts. So inside the lab, every lab will start with an overview, and then what specifically it is that you're going to do. Inside of this lab, since you're a data analyst, you're going to be creating spreadsheets and adding files and sharing files with some of your other data analysts. If you forget what section you're in, another pro tip that I like to do is on the right-hand side, you can actually click between each of the different header sections right here as I'm doing now, and you can jump to a particular section inside of the workbook. So say you and your friends are working on this together, you can say, hey, I'm having trouble on the share and collaborate section. You can just click on that and it'll jump right to that section. Well, that's pretty much it. A few more housekeeping items and then you're off to the races. As you work your way through the lab, you want to make sure that you're completing the objectives and making sure that you're staying on track. There is intelligence built into the quick labs to prevent any kind of behavior that's not part of the lab. So make sure you're following the lab as is. And when you're done with the lab, say I was completed here, all you have to do is click on End Lab, click on OK, and that's going to bring you to a pop-up screen that asks you to rate the lab, add in any comments for the lab authors like me, submit it, and then automatically your score for the work that you've done in the lab is fed back to Coursera, which is pretty cool. And that's it. That was a quick tour of a quick lab. It was about 5 minutes, but honestly, you'll have a blast going through these. Good luck.
Hi again. Let me ask you something. What comes to your mind when you think of the word ethics? For me, it's a set of principles to live by. Most people have a personal code of ethics that helps them navigate the world. When we're young, it could be as simple as never lie, cheat, or steal. But as we get older, it's a much broader list of do's and don'ts. Our personal ethics evolve and become more rational, giving us a sort of moral compass to use as we face life's questions, challenges, and opportunities. When we analyze data, we're also faced with questions, challenges, and opportunities. But we have to rely on more than just our personal code of ethics to address them. As we learned earlier, we all have our own personal biases, not to mention subconscious biases that make ethics even more difficult to navigate. That's why we have data ethics, an important aspect of analytics that we'll explore right here in this video. But first, let's go back to the general idea of ethics. While an exact definition is still under discussion in philosophy, one practical view is that ethics refers to well-founded standards of right and wrong that prescribe what humans ought to do, usually in terms of rights, obligations, benefits to society, fairness, or specific virtues. And just like humans, data has standards to live up to as well. Data ethics refers to well-founded standards of right and wrong that dictate how data is collected, shared, and used. Since the ability to collect, share, and use data in such large quantities is relatively new, the rules that regulate and govern the process are still evolving. The importance of data privacy has been recognized by governments worldwide, and they've started creating data protection legislation to help protect people and their data. The GDPR of the European Union was created to do just this. While policymakers continue their work, companies like Google have a responsibility to lead the effort, and will do so in the same spirit we always have, by offering products that make privacy a reality for everyone. The concept of data ethics and issues related to transparency and privacy are a part of the process. Data ethics tries to get to the root of the accountability companies have in protecting and responsibly using the data they collect. There are lots of different aspects of data ethics, but we'll cover 6: ownership, transaction transparency, consent, currency, privacy, and openness. We'll explore data privacy and openness a bit later. First up is ownership. This answers the question, who owns data? It isn't the organization that invested time and money collecting, storing, processing, and analyzing it. It's individuals who own the raw data they provide, and they have primary control over its usage, how it's processed, and how it's shared. Next, we have transaction transparency, which is the idea that all data processing activities and algorithms should be completely explainable and understood by the individual who provides their data. This is in response to concerns over data bias, which we discussed earlier is a type of error that systematically skews results in a certain direction. Biased outcomes can lead to negative consequences, so to avoid them, it's helpful to provide transparent analysis, especially to the people who share their data. This lets people judge whether the outcome was fair and unbiased and allows them to raise potential concerns. Now let's talk about another aspect of data ethics: consent. This is an individual's right to know explicit details about how and why their data will be used before agreeing to provide it. They should know answers to questions like, why is the data being collected? How will it be used? How long will it be stored? The best way to give consent is probably a conversation between the person providing the data and the person requesting it. But with so much activity happening online these days, consent usually just looks like a terms and conditions checkbox with links to more details. Let's face it, not everyone clicks through to read those details. Consent is important because it prevents all populations from being unfairly targeted, which is a very big deal for marginalized groups who are often disproportionately misrepresented by biased data. Next, there's currency. Individuals should be aware of financial transactions resulting from the use of their personal data and the scale of these transactions. So if your data is helping to fund a company's efforts, you should know what those efforts are all about and be given the opportunity to opt out. The last two aspects of data ethics, privacy and openness, deserve their own spotlight on this data stage. Coming up, you'll see why.
Hi, I'm Alex. I'm a research scientist at Google. My team is called the Ethical AI team, and we're a group of folks that really are concerned not only about how AI and the technology operates, but how it interacts with society and how it might help or harm marginalized communities. So when we talk about data ethics, we think about, what is the good and right way of using data? What are going to be ways that are going to be uses of data that are going to be beneficial to people? When it comes to data ethics, it's not just about minimizing harm, but it's actually this concept of beneficence. How do we actually improve the lives of people by using data? When we think about data ethics, we're thinking about who's collecting the data, why are they collecting it, how are they collecting it, and for what purpose. Because of the way that organizations have imperatives to make money or to report to somebody or provide some kind of analysis, we also have to keep strongly in mind how this is actually going to benefit people at the end of the day. Are the people represented in this data going to be benefited by this? And I think that's the thing you never want to lose sight of as a data scientist or a data analyst. I think aspiring data analysts need to keep in mind that a lot of the data that you're going to encounter is data that comes from people. So at the end of the day, data are people. And you want to have a responsibility to those people that are represented in those data. Second is thinking about how to keep aspects of their data protected and private. We don't want to go through our practice thinking about data instances as something we could just throw on the web. No, there needs to be considerations about how to keep that information and likenesses like their images or their voices or their text. How do we keep that private? We also need to think about how we can have mechanisms of giving users and giving consumers more control over their data. It's not going to be sufficient just to say we collect all this data and trust us with all these data, but we need to ensure that there's actionable ways in which people can consent to giving those data and ways that they can ask for it to be revoked or removed. So data is growing, and at the same time, we need to empower people to have control over their own data. The future is that data is always growing. We haven't seen any kind of evidence that data is actually shrinking. And with the knowledge that data is growing, these issues become more and more peaked and more important to think about.
We've been exploring some important aspects of data ethics, and one of the most personal areas involves privacy. Privacy is personal. We may all define privacy in our own way, and we're all entitled to it. Whether it's family members wanting privacy when using a shared computer, a teenager wanting to share a selfie with only specific people, or a company wanting to keep their customers' credit card info secure, we're all concerned how our data is used and shared. Data privacy is big in today's culture, so let's explore it fully. When talking about data, privacy means preserving a data subject's information and activity anytime a data transaction occurs. This is sometimes called information privacy or data protection. It's all about access, use, and collection of data. It also covers a person's legal right to their data. This means someone like you or me should have protection from unauthorized access to our private data, freedom from inappropriate use of our data, the right to inspect, update, or correct our data, ability to give consent to use our data, and legal right to access our data. For companies, it means putting privacy measures in place to protect the individual's data. Data privacy is important, even if you're not someone who thinks about it on a day-to-day basis. The importance of data privacy has been recognized by governments worldwide, and they've started creating data protection legislation to help protect people and their data. Being able to trust companies with your data is important. It's what makes people want to use a company's product, share their information, and more. Trust is a really big responsibility that can't be taken lightly. The final aspect involving data ethics is one that's constantly being discussed: the idea of openness, free access, usage, and sharing of data. We'll cover that in another video. You're well on your way to becoming an ethical data analyst.
My name is Andrew. I am a senior developer advocate on the Ethical AI Research Group at Google. As a senior developer advocate, I try and help the larger community build socially responsible AI systems. One consequence of not using this technology responsibly is the possibility of amplifying or reinforcing unfair biases. Now, these algorithms, these data sets are often being used in settings where they are deciding the outcome, whether it's curating content for an individual or determining whether or not they're eligible for a loan. All of these different decision-making processes depend on the algorithms and the data sets that are being used in that context. And so if this were to be handled irresponsibly, then the very outcomes of these systems could potentially harm underrepresented communities, minority groups. There's a lot that the field, the industry, the community is learning about the responsible use of data and AI. So what I try to do is I try to collate all those different elements, whether it's working with various research groups within Google, working with various product teams at Google, engaging with the larger community. We have to go above and beyond and actually educate those that are striving to build this technology for good, but may not necessarily have the resources or the institutional community wisdom to actually carry out their good intentions. So the truth of the matter is that AI, data, and any technology that's built around that, there's a lot of great benefits to that. It's improving the lives of many people out there. It's enabling us to do things we couldn't ordinarily do. It's providing us with affordances to think about other things in life. This is all the more reason why it's important that we together collectively, not just one organization, but the entire community, and even non-technologists too. Everyone needs to be involved. That's the role that I play here, is that I try to help AI evolve ethically together. And to do that is contingent on the democratization of the responsible use of AI.
Ready to get back into it? Great. There's just something so liberating about being able to find information on any subject at all on the internet. Can't remember the third line of your favorite childhood song? Curious who had the most home runs in 1986? Want to teach yourself sign language? Just pop open your laptop, type up some text, and poof, you have what you need. Many groups think we should also have this level of access to data. There's even a global movement that believes the openness of data can transform society and how decisions are made. So far, we've talked a lot about the power of data and the importance of data ethics concerns, including ownership, transaction transparency, consent, currency, and privacy. Now, let's talk about openness. When referring to data, openness refers to free access, usage, and sharing of data. Sometimes we refer to this as open data, but it doesn't mean we ignore the other aspects of data ethics we covered. We should still be transparent, respect privacy, and make sure we have consent for data that's owned by others. This just means we can access, use, and share that data if it meets these high standards. For example, there are standards around availability and access. Open data must be available as a whole, preferably by downloading over the internet in a convenient and modifiable form. The website data.gov is a great example of this. You can download science and research data for a wide range of industries in simple file formats like a spreadsheet. Another standard surrounds reuse and redistribution. Open data must be provided under terms that allow reuse and redistribution, including the ability to use it with other datasets. And the last area is universal participation. Everyone must be able to use, reuse, and redistribute the data. There shouldn't be any discrimination against fields, persons, or groups. No one can place restrictions on the data, like making it only available for use in a specific industry. Now let's talk a little more about why open data is such a great thing and how it can help you as a data analyst. One of the biggest benefits of open data is that credible databases can be used more widely. More importantly, all of that good data can be leveraged, shared, and combined with other data. Just imagine the impact that would have on scientific collaboration, research advances, analytical capacity, and decision-making. For example, in human health, openness allows us to access and combine diverse data to detect diseases earlier and earlier. In government, it can help hold leaders accountable and provide better access to community services. The possibilities and the benefits are almost endless. But of course, every big idea has its challenges. A whole lot of resources are needed to make the technological shift to open data. Interoperability is key to open data's success. Companies have to cooperate and work together to make data useful. Databases must be accessible with common formats and terminology. And then there's the bigger cultural shift that needs to happen, where we stop seeing databases as restricted intellectual property and start looking at them as a common good. While there's serious potential in the open, timely, fair, and simple sharing of data, its future will depend on how effectively these challenges are addressed. As a data analyst, I say the sooner the better. Speaking of which, we're going to talk more about open data and see its use in action in an upcoming video. Now that you've learned all about data ethics, you have some very important principles to guide you on your data journey. Anytime you're not sure of your data, remember what you've learned here. Happy trails.
My name is Andrew. I am a senior developer advocate on the Ethical AI Research Group at Google. As an analyst, there's quite a few things you can do as you're evaluating your data set in order to ensure that you are looking at it through the various ethical lenses. One of which is being to self-reflect and understand what it is that you're doing and the impact that it has. And the best way to challenge that is to question who we are. We being like, okay, we in this team are trying to build this because we think that that's going to help improve this product, or that's going to help inform decisions about what we want to do next. Think about not just those that sit laterally next to you, but also think about those that are represented in this data set and those that aren't represented in this data set. And then use that intuition to then continue to question the integrity, the quality, the representation, that is present in that data set. And then also think about the various harms and risks associated with the work that you're doing. For example, if you find that you think that you'll benefit from keeping the data set longer, you may want to also understand what's the risk of holding on to this data set? What's the potential harm that could arise if you continue to look at this data set and continue to store it and continue to retrieve this data? And going beyond that, also understanding what's the consent process like? Are you informing those that you're collecting data from how it's going to be used? What's the communication channel like? Putting on the various ethical lenses, taking a more nuanced approach to your analysis, being cognizant of all the possible risks and harms that can arise when not just analyzing your data set, but also presenting your data set, how you portray the results, how they're being used in the decision-making process, whether you are presenting this to management or presenting this to executives or presenting this to a larger audience. All of that matters in the responsible use of the data set. As a data analyst, you stand in the intersection between the very people that will stand to benefit from the technology that's being developed and those in your organization that are trying to make a more informed decision as to whether or not to move forward with the productionization of the technology. It may feel like there's a lot of weight there, and there is, but it's also very pivotal, and it speaks to the volume of the impact of your work.
Hello again. So far you've seen how data can be gathered and analyzed to solve all kinds of problems. Next up, we're going to learn all about databases. As a refresher, a database is a collection of data stored in a computer system, but storage is just the beginning. You'll discover how databases make it possible to find the exact piece of information you need for your analysis. You'll also learn how to sort data in order to zoom in on what you need, to generate insightful reports, and much more. Then we'll go even deeper, and I mean really, really deep. I'm talking about metadata. You've probably heard someone say, wow, that's so meta. Usually, they're talking about something referencing back to itself or being completely self-aware. For example, if a character in a book knows she's in a book, that's meta. If you make a documentary about making documentaries, that's also meta. And here at Google, I constantly analyze how I analyze data. That's definitely meta. I do that to give my work a quality check, to make sure my methods are fair, and to be certain that I'm paying attention to any biases that might affect the outcome. As an analyst, you should do this too. Sometimes we get a little too close to our data, so stepping back and asking ourselves if our processes make sense is key. But let's back up just a bit and define metadata. Metadata is data about data. Like I said, deep. Metadata is extremely important when working with databases. Think of it like a reference guide. Without the guide, all you have is a bunch of data with no context explaining what it means. Metadata tells you where the data comes from, when and how it was created, and what it's all about. Up next, you'll learn how to take data from a database or another source and bring it into a spreadsheet. You'll do this either by importing it directly or by using SQL to generate the request. And once you have data in a spreadsheet, the possibilities are endless. Everything we're about to cover is a very important part of the prepare phase of the data analysis process. It's how data analysts figure out which kind of data is going to be most helpful to them. And if you have the right data, you're much more likely to be able to solve your business problems successfully. So ready to tap into the incredible power of databases? Let's go. Databases are essential tools for data analysts. I use them constantly. Just about all of the data I access is stored within databases. Databases store and organize data, making it much easier for data analysts to manage and access information. They help us get insights faster, make data-driven decisions, and solve problems. You've already heard a bit about what databases are and how they're used by data analysts. Now, let's learn more about database features and components. As you've learned, a database is a collection of data stored in a computer system. Here's a simple database structure. It contains tables with information from a car manufacturer. The top level includes car dealerships, product details, and repair parts. Then, if you drill down to the next level by selecting one of those tables, you'll find more specific details about each item. This is called a relational database. A relational database is a database that contains a series of tables that can be connected to form relationships. For two tables to have a relationship, one or more of the same fields must exist inside both tables. For example, here, branch ID exists in this table and this one. If a field exists within both tables, we can use it to connect the tables together. Certain fields can also be referred to as a primary key. A primary key is an identifier that references a column in which each value is unique. So in our car manufacturer example, we can see that branch ID is the primary key in the dealership table, VIN is the primary key in the product details table, and part ID is the primary key in the repair parts table. Primary keys are unique and can only exist once within a given table. There's also foreign keys. A foreign key is a field within a table that's a primary key in another table. So in our example, the VIN is the foreign key in the repair parts table. As you can see, a table can only have one primary key, but it can have multiple foreign keys. Relational databases are great for keeping data consistent, no matter where it's accessed. Mobile banking is an interesting example of this. Let's say you deposit a check into your bank account using your mobile banking app. Then you check your account balance on your computer. The database relationship makes sure that the deposit shows up immediately on both platforms. Or let's say you work on a team of data analysts located in different offices. Relational databases make sure everyone's looking at the exact same data and can collaborate using a single set of accurate information. Now let's explore some different types of relational databases. First, a normalized database is a database in which only related data is stored in each table. The main idea behind database normalization is that a table should be about a specific topic and only include supporting related data. This is important because it minimizes the chances of having redundancies. A redundancy occurs when the same piece of data is stored in two or more separate places. Redundancies waste time and space in your database. For example, if you needed to change a piece of data in a database with redundancies, you'd have to make the same update in every place where the data exists. That would take a lot of time and could easily lead to typos or other errors. Next up, we have schemas. A schema is a way of describing the way something is organized. You can think about data schemas like blueprints of how the database is constructed. Schemas are useful when you're learning about a new data set or designing a relational database. You'll learn more about different types of schemas in an upcoming reading. All right, you've learned a lot about databases and how data analysts use them to gain important insights every day. Soon you'll begin practicing how to access and analyze data from actual databases. That will be a great opportunity to improve your understanding of database organization, the benefits of each method, and how you might use databases in your future analytics career. Now that you understand the different ways to organize data in a database, let's talk about how you can describe that data. In this video, we'll start exploring metadata, which is a very important aspect of database management. Metadata is kind of an abstract concept, though. So let's kick things off with a simple, everyday example. Did you know that every time a photo is taken with a smartphone, data is automatically collected and stored within that photo? Take a look. Choose any photo on your computer. Here's a cute shot of my friend's dogs, Rudy and Matilda. On your photo, right-click on Get Info or Properties. This will give you the photo's metadata, which may tell you the type of file it is, the date and time it was taken, the geolocation or where it was taken, what kind of device was used to take the photo, and much more. Pretty amazing, right? Here's another example. Every time you send or receive an email, metadata is sent right along with that message. You can find it by clicking on Show Original or View Message Details. An email message's metadata includes its subject, who it's from, who it's to, and the date and time it was sent. The metadata even knows how quickly it was delivered after the sender pressed send. Okay, so metadata is information that's used to describe the data that's contained in something, like a photo or an email. Keep in mind that metadata is not the data itself. Instead, it's data about the data. In data analytics, metadata helps data analysts interpret the contents of the data within a database. That's why metadata is so important when working with databases. It tells an analyst what the data is all about. That makes it possible to put the data to work solving problems and making data-driven decisions. As a data analyst, there are 3 common types of metadata that you'll come across: descriptive, structural, and administrative. Descriptive metadata is metadata that describes a piece of data and can be used to identify it at a later point in time. For instance, the descriptive metadata of a book in a library would include the code you see on its spine, known as a Unique International Standard Book Number, also called the ISBN. It would also include the book's author and title. Next is structural metadata, which is metadata that indicates how a piece of data is organized and whether it's part of one or more than one data collection. Let's head back to the library. An example of structural data would be how the pages of a book are put together to create different chapters. It's important to note that structural metadata also keeps track of the relationship between 2 things. For example, it can show us that the digital document of a book manuscript was actually the original version of a now printed book. Finally, we have administrative metadata. Administrative metadata is metadata that indicates the technical source of a digital asset. When we looked at the metadata inside the photo, that was administrative metadata. It showed you the type of file it was, the date and time it was taken, and much more. Here's one final thought to help you understand metadata. If you're on your way to the library to pick out a book, you could research a book's title, author, length, and number of chapters. That's all metadata, and it can tell you a lot about the book. But you have to actually read the book to know what it's all about. Likewise, you can read about data analytics, but you have to take this course to earn the Google Data Analytics certificate. So keep moving forward to gain that new perspective. Now that you know what metadata is, it's time to explore why data analysts use it. You already know that data needs to be identified and described before it can help you solve a problem or make an effective business decision. Putting data into context is probably the most valuable thing that metadata does. But there are still many more benefits of using metadata. Here's one. Metadata creates a single source of truth by keeping things consistent and uniform. We data analysts love consistency, so we always aim for this kind of uniformity in our data and our databases. After all, data that's uniform can be organized, classified, stored, accessed, and used effectively. Plus, when a database is consistent, it's so much easier to discover relationships between the data inside it and the data elsewhere. Metadata also makes data more reliable by making sure it's accurate, precise, relevant, and timely. This also makes it easier for data analysts to identify the root causes of any problems that might pop up. The bottom line is, when the data we work with is high quality, it makes things easier and improves our results. One of the ways data analysts make sure their data is consistent and reliable is by using something called a metadata repository. A metadata repository is a database specifically created to store metadata. Metadata repositories can be stored in a physical location or they can be virtual, like data that exists in the cloud. These repositories describe where metadata came from, keep it in an accessible form so it can be used quickly and easily, and keeps it in a common structure for everyone who may need to use it. Metadata repositories make it easier and faster to bring together multiple sources for data analysis. They do this by describing the state and location of the metadata, the structure of the tables inside, and how data flows through the repository. They even keep track of who accesses the metadata and when. Here's a real-world example. As a healthcare analyst at Google, I use second and third-party data. As you learn, second-party data is data that's collected by a group directly from its audience and then sold. And third-party data comes from outside sources, which are not the original collectors of that data. They get it from websites or programs that pull the data from the various platforms where it was originally generated. It's a bit complex, but the main thing to remember is that third-party data doesn't come from inside your own business. So if my team needs to work with data that wasn't created at Google, that means we sometimes don't know very much about its quality and credibility. But we need to be certain that our data can be trusted and was collected responsibly. After all, if the data is unreliable, our results can be unreliable too. That's why understanding the metadata of the external database is so important. It lets us confirm that the data is clean, accurate, relevant, and timely. This is particularly important if the data comes from another organization. One other important step when working with external data is confirming that we're allowed to use it. We'll often reach out to the owner to make sure we can access or purchase it. So to sum up, metadata repositories are useful for all these reasons. Plus, they help ensure that my team is pulling the right content for the particular project and using it appropriately. We can confirm this because the metadata clearly describes how and when the data was collected, how it's organized, and much more. Soon you'll learn even more about using metadata in data analytics. And if you're finding metadata particularly fascinating, you'll discover some really exciting career choices that focus on metadata. Stay tuned. Metadata and metadata repositories are very powerful tools in the data analyst toolbox. As we discussed previously, data analysts use them to create a single source of truth, keep data consistent and uniform, and ensure that the data we work with is accurate, precise, relevant, and timely. These tools also make it easier to access and use data by standardizing our processes. In this video, we'll explore more components of metadata and learn how metadata analysts work to keep things organized. We know that the amount of data out there continues to grow, but lots of businesses just aren't using their data. Sometimes they don't know what they have. Sometimes they can't find it. Or sometimes a business just doesn't trust it. Especially in bigger companies, data can span numerous different processes and systems. And pulling together data from so many places can be a big challenge. For example, let's say a company starts out with a traditional data storage system in its offices. But then, as the amount of data it owns continues to expand, cloud storage is needed too. Plus, this company could also be accessing and using second or third-party data from a partner organization. Each of these systems has its own rules and requirements, so each organizes the data in a completely different way, adding even more complexity. It's no wonder so many organizations struggle to find the right data at the right moment. On the other hand, metadata is stored in a single, central location and gives the company standardized information about all of its data. This is done in two ways. First, metadata includes information about where each system is located and where the datasets are located within those systems. Second, the metadata describes how all of the data is connected between the various systems. Another important aspect of metadata is something called data governance. Data governance is a process to ensure the formal management of a company's data assets. This gives an organization better control of their data and helps a company manage issues related to data security and privacy, integrity, usability, and internal and external data flows. It's important to note that data governance is about more than just standardizing terminology and procedures. It's about the roles and responsibilities of the people who work with the metadata every day. These are metadata specialists, and they organize and maintain company data, ensuring that it's of the highest possible quality. These people create basic metadata identification and discovery information, describe the way different datasets work together, and explain the many different types of data resources. Metadata specialists also create very important standards that everyone follows and the models used to organize the data. And there's one thing they all have in common. Whether they work at a tech company, a nonprofit association, or a financial institution, metadata analysts are great team players. They're passionate about making data accessible by sharing with colleagues and other stakeholders. So if you're looking for a role that encourages you to explore all the data that the digital world has to offer, following the path to becoming a metadata analyst may be the right choice for you. But either way, businesses of all kinds face market trends and competition, and they need to understand why one process works while another doesn't. Data analytics allows them to answer key questions and keep improving.
My name is Megan, and I am an agency measurement lead here at Google. Basically, I help to demystify measurement and analytics for advertising agencies. So people that are tasked with executing media plans for advertisers, but also people that are interested in measuring the impact that media is having for their clients. So I've been doing this for about 17 years now and have seen a lot of evolution in the space, from data availability, from different modeling techniques becoming more advanced, but also more accessible. And it's just been a really cool journey to see how it's evolved, how analytics has become more mainstream, and how people are getting more excited about it. Metadata is basically the key to your larger data set. It helps describe what's in the rows and the columns of the data that you'll be working with. Metadata is kind of a shorthand or a CliffsNotes version of a much more complex set of information. It can be helpful in just kind of helping you get a handle on what's in a single data set that you may have access to. It's an important part of the discovery process of any analytics project as you're working with either a client or a vendor to understand the resources that you'll have to address a problem and what might be missing. It just gives you, the keys to unlock that data in a really simple and straightforward way, and is a great communication tool. When I was working for an advertiser, one of the things that we were trying to do was build something called a data lake. So essentially, this is bringing together all of the sources of data that you might want to use in an analysis into one place, which can be really, really tricky. One of the benefits of metadata was figuring out where we had sources that may overlap, where we had data sources that had things in common, and what the unique pieces of information were that we were getting from each of those data sets. So as we thought about tackling this really huge and important project, we were able to use metadata to quickly and easily get to the basic constructs that we were trying to tackle. When you're working with people who maybe don't have analytics as their day job, getting that aha moment, helping them understand how measurement and analytics are tools that can help them achieve their goals is really important. And just getting to that idea of, you made something that was previously inaccessible a little bit more accessible for that team and something they feel comfortable putting into practice is really important and really kind of a great way to come out of a partnership.
In this video, we'll discuss the different places data analysts go to connect with data. There's all kinds of data out there, and it's important to know how to access it. Earlier, you learned that there are two basic types of data used by data analysts: internal and external. Internal data is data that lives within a company's own systems. It's typically also generated from within the company. You may also hear internal data described as primary data. External data is data that lives and is generated outside an organization. It can come from a variety of places, including other businesses, government sources, the media, professional associations, schools, and more. External data is sometimes called secondary data. Gathering internal data can be complicated. Depending on your data analytics project, you might need data from lots of different sources and departments, including sales, marketing, customer relationship management, finance, human resources, and even the data archives. But the effort is worth it. Internal data has plenty of advantages for a business. It provides information that's relevant to problems you're trying to solve, and it's free to access because the company already owns it. With internal data, analysts can work on all sorts of data projects without ever looking beyond their own walls. But sometimes internal data doesn't give you the full picture. In those cases, data analysts can turn to external data and apply that information to their analysis. For instance, as healthcare analysts, we often partner with other healthcare organizations or nonprofits and use their data to create deeper analyses and add some more industry-level perspective. In an earlier video, you learned that OpenNIST has created a lot of data for analysts to use, largely through open data initiatives. As a reminder, openness or open data refers to the free access, usage, and sharing of data. For example, the United States government makes hundreds of thousands of data sets available to the public on data.gov. These data sets contain information on weather patterns, educational progress, crime rates, transportation, and much more. There are lots of reasons for these open data initiatives. One is to make government activities more transparent, like letting the public see where money is spent. It also helps educate citizens about voting and local issues. Open data also improves public service by giving people ways to be a part of public planning or provide feedback to the government. And finally, open data leads to innovation and economic growth by helping people and companies better understand their markets. Google actually hosts lots of public databases with information on science, transportation, economics, climate, and more. So as an example, a bike-sharing company could use traffic data from within our public transportation database to see where the roads are busiest, then choose those locations for their bikes in order to reduce cars on the road and give people another transportation option. So now you're familiar with internal and external data and how you can access both. Coming up, we'll learn how to import all the data you collect from different sources into a spreadsheet. At this point, you've learned all about internal and external data and how to prepare it for use. Now we'll go through the process of actually importing data from different sources. Sometimes you'll want to upload a spreadsheet from your files, such as a CSV file. CSV stands for comma separated values. A CSV file saves data in a table format. Now let's bring that file into a fresh spreadsheet. We'll start by selecting a file, then import. Then we'll choose to upload a file. Navigate to it, open it, and insert it as a new sheet. CSV files use plain text and they're delineated by characters, so each column or field is clearly distinct from another when importing. As you learned, CSVs are comma separated, and usually the spreadsheet app will auto-detect those separations, but sometimes you might need to indicate that the separator is another character or a space by selecting the different options in this window. Also, if you are planning to work with the dataset, you would usually convert to text, numbers, or other options here. But plain text is okay for reporting purposes, so we can leave those fields alone. Finally, select Import Data. Now our CSV file is ready to work with in our spreadsheet. I spend most of my time at work analyzing spreadsheets full of healthcare information. I typically start by looking at a larger dataset, then I pull a subset of it into a spreadsheet so I can work with it. Maybe I want to analyze year-over-year growth in user demand on Google Search for certain healthcare services like telemedicine. Or maybe I want to look at data sets from external healthcare organizations or agencies for more insight into this trend. For example, with telemedicine, maybe I'll look at a spreadsheet that lists telemedicine providers. There are so many ways spreadsheets can help you find the insights you need. One source I use a lot is the World Health Organization's data repository. This is a place where anybody can access open source data. As you can see, there's tons of data available. You can search by theme, category, indicator, and country. You can also access World Health Organization metadata if you want to learn more about the data in the repository. For our example, we'll look at medical doctors by country and year. This information would be useful for a data analysis project looking into how many doctors are available to treat patients within a certain population, compared to other populations. To get this data, we'll start on this webpage, which contains the dataset we want. Then we'll download the data as a CSV file. Then open a new spreadsheet and import the file by selecting File, Import. Next, upload your file and select Import Data. After reviewing the data to make sure it looks clean, we can title it and begin our work. I know this is a lot of information to take in, but you'll get much more comfortable with this the more you practice. Coming up, we'll learn how to sort and filter your data to focus on the information relevant to you. In the past few videos, you've learned about both internal and external data. Now I'll show you how to focus on only the data that's relevant to the problem you're trying to solve. This is useful if you're working with a very large, complex spreadsheet, which data analysts encounter all the time. Having lots of data can make it difficult to quickly find and analyze the information you need. No two analytics projects are the same. Often, data analysts process, view, and use data very differently, even if it comes from the exact same source. Here's an example. Check out this spreadsheet that shows a company's sales reps and where they work. Different data analysts might want different information from this spreadsheet, and that's where sorting and filtering comes in. Sorting and filtering the data in a spreadsheet helps us customize the way data is presented. They can also organize data so analysts can zoom in on the pieces that matter. Think of it like a magnifying glass for our data. Let's begin with sorting. Sorting involves arranging data into a meaningful order to make it easier to understand, analyze, and visualize. Data can be sorted in ascending or descending order, and alphabetically or numerically. Sorting can be done across all of a spreadsheet or just in a single column or table. You can also sort by multiple variables. For instance, if our dataset contains both city and state fields, we can sort first by city and then by state. Anytime you're sorting data, it's always a good idea to freeze the header row first. To do this, we'll highlight the row. Then from the View menu, choose Freeze and One Row. This locks the row in place. Now, when we scroll down the sheet, the header row stays visible so we know the category of each column. Looks good to me. Now let's sort the entire spreadsheet. We'll sort by city first. To do this, select the city column. Then use the drop-down arrow to sort the sheet. Select A to Z. This will sort all of the columns from A to Z by row, with the selected column being the primary sort criteria. The cities are now sorted alphabetically, and they're still grouped with the corresponding states, sales reps, and auto parts. The details across each row are automatically kept together when sorting a particular section, as you can see here. Multiple criteria sorting is another very useful data analysis tool. For instance, let's say we want to see a list of sales reps by the cities and states in which they work. First, we select the entire dataset. Then choose Data and Sort Range. In the dialog box, make sure that Data has header row is highlighted. That way, row A, city, states, sales rep, and auto parts won't be part of the sort. Then in the Sort By drop-down menu, select state and the sort order A to Z. Now add another sort column. In the Then By drop-down, select city and the sort order A to Z. Finally, select Sort. Now we can search the data to easily find a sales rep who works in a particular state and city. Sorting is useful when you want to look at everything in a spreadsheet in alphabetical or numerical order, but sometimes data analysts want to isolate a particular piece of information. To do this, they use a filter. Filtering means showing only the data that meets a specific criteria while hiding the rest. A filter simplifies a spreadsheet by only showing us the information we need. For example, we could add a filter to see only the sales reps who work with a particular product. To do this, we first select Data and create a filter. Choose the column with the data we need, in this case, auto parts. Filter buttons will appear in the corner of each column header. To filter our spreadsheet by auto part, click the button in the auto parts header. In this example, let's say we want to only see sales reps who work with rims. Remove the check marks from the categories we don't want to see, which is everything except for rims. Then select OK. The filter temporarily hides anything that doesn't meet the condition, but note that even though they aren't visible, they're still there. When it's time to view the entire area spreadsheet again, simply turn off the filter. Sorting and filtering are very important tools in the data analyst's toolbox. In the next video, you'll discover even more ways to narrow in on the exact information you need for any data analysis project. You've learned how sorting and filtering data in spreadsheets helps data analysts customize the information. Customizing data makes it more meaningful and easier to understand, analyze, and visualize. You also discovered that some spreadsheets can be extremely long and complex, so knowing how to zero in on the exact data you need while setting aside the rest helps you focus on your analysis. This is also true for databases. Sometimes a dataset is too large to download, or it won't fit in a spreadsheet. So a data analyst will use SQL to create a query to view the specific data that they want from within the larger set. We've learned that a database is a collection of data stored in a computer system, and that SQL stands for Structured Query Language. Data analysts use query languages to communicate with the database. In an earlier video, you also learned that a relational database contains a series of tables that can be connected to form relationships. These relationships are represented by primary and foreign keys. Data analysts write queries in order to get data from these tables. Let's see how this works. We'll start with our table viewer. Here we can see what public datasets are available. We'll scroll through the data before we start using it to get a feel for what it's all about and to make sure it's clean. Some table viewers let you preview a few rows before even writing a query. This is helpful if you want to take a quick look to be sure the dataset will be right for your project. To show you how this works, let's check out a sample dataset. This one shows how much sunlight hits rooftops in a year. This would be very useful for a data analyst working on a solar energy project, for example. We'll start by previewing the dataset. Click on it like this. Then we'll select a subset of this data where we find regions, states, yearly sunlight, and more. Now to see the entire dataset, let's write a query. The first step is finding out the complete correct name of the dataset. To do this, select the dataset, Solar Potential by Postal Code, and select Query Table. The name of the dataset is shown inside the two backticks. This is to help us read the query more easily. We can also remove the backticks in this case, and our query would still run. The words you see before the dot represent the database name. And the words after the dot represent the table name. Let's select and copy the dataset name now, because we'll need it in a second. Now we'll click on the plus sign to compose a new query. Most queries begin with the word select. Then we add a space. Because we want to see the entire dataset, we'll put an asterisk next. The asterisk says we want to include all columns. This is a great shortcut because without it, we'd have to type in every single field name. Next, we'll press return and type from. From does just what it sounds like. It indicates where the data is coming from. After that, we'll add another space. Now we paste in the name of the dataset that we copied earlier. And finally, run the query. Now we can carefully inspect the dataset before we begin working with it. One important thing to keep in mind, SQL queries can be written in a lot of different ways, but still provide the same results. For example, we could have written this query as one long line of instructions, like this. And we'd still get the same results. The additional lines and spaces don't impact the query's outcome, but they keep your query organized and easier to read for yourself and others. Now, if the project doesn't require all of these fields, we can use SQL to view a particular piece or pieces of data. To do this, we specify a certain column name in the query. For example, maybe we only want to see data from Pennsylvania. So we'd begin our query the same way we just learned. Select, space, add an asterisk. Then, from our solar potential database. But this time, we'll add where. Where also does exactly what it sounds like. It tells the database where to look for information. In this case, the state name column. So add a space and state_name, the name of the column. Now, because we only want to see data from Pennsylvania, we add an equal sign and the word Pennsylvania with single quotes around it. In SQL, single quotes indicate the beginning and ending of a string. Finally, rerun the query. Now we can review the data on solar potential for only Pennsylvania. Now we've got the data we want and we're ready to start putting it to work, which we'll cover later on. But for now, let's celebrate finishing another module. You've covered a lot of complex and highly technical information. As you keep practicing though, things will start to feel a lot more natural. For now, take a moment to sit back and think about all you've learned. You discovered metadata and how it keeps data organized by describing what that data is all about. You've seen how internal and external data are accessed and how data analysts use them to find compelling insights to solve business problems. And you can sort and filter your data to really pinpoint the information you need. Finally, you just learned about queries and you even practiced writing some. Coming up, you'll have a few readings and then a weekly challenge to test your knowledge. This will help you confirm that you've understood what we've worked on in these videos. And as always, if you're ever unsure about a question, I highly encourage you to review the videos and readings to find the answer. You're the data detective now, so use those skills. Keep up the great work, and I'll see you after the weekly challenge. Hey, good to have you back. Up until now, we focused on preparing your data for processing and analysis. In these next videos, we'll explore another big part of that process: organizing and protecting your data. Keeping your data organized is important for a few reasons. It makes it easier to find and use, helps you avoid making mistakes during your analysis, and helps to protect it. Coming up, we'll go over the basics of organizing data for personal and professional use and file naming conventions. Then we'll take a look at some security features for spreadsheets. By the end of these next few videos, you'll be able to do all these things, and you'll be able to explain these steps to stakeholders so they can feel confident that your data practices are safe and secure. When you're ready to get started, go ahead to the next video. There, we'll get started with organizing data for personal use. Hey, welcome back. Whether you're organizing your personal data for your own use or organizing project data for work, there are certain procedures you want to follow to make sure your data is easy to find and use. In this video, we'll cover some best organization practices and also check out some different ways project data can be organized. There are plenty of best practices you can use when organizing data, including naming conventions, foldering, and archiving older files. We've talked about file naming before, which is also known as naming conventions. These are consistent guidelines that describe the content, date, or version of a file in its name. Basically, this means you want to use logical and descriptive names for your files to make them easier to find and use. And speaking of easily finding things, organizing your files into folders helps keep project-related files together in one place. This is called foldering. For example, all of the files related to your vacation plan might go in the Vacation 2025 folder. You might then break that folder down even further by creating subfolders like itinerary or photos, depending on what else you'd like to easily access. It can also be useful to move old projects to a separate location to create an archive and cut down on clutter. It's so much easier to find and use my files when I name them something meaningful and searchable, and when I organize them into folders. It makes all my data more accessible and useful. In addition to these 3 best practices, there are 2 more things you'll want to consider when organizing data for work use. First, the project data you'll be using for work could be accessed and used by multiple people. So it's important to align your naming and storage practices with your team to avoid any confusion. Your team might also develop metadata practices like creating a file that outlines project naming conventions for easy reference. We'll get to talk more about naming conventions for work files in more detail later. Secondly, you want to think about how often you're making copies of data and storing it in different places. Most importantly, because if data is stored in lots of different databases or spreadsheets, it can contradict itself and lead to mistakes later on. Also, storing data in multiple places takes up a lot of space. Relational databases can help you avoid data duplication and store your data more efficiently. You can use these practices to organize data in different ways according to your project. So let's look at some examples of data organization. I have some sample project folders here, each organized in a slightly different way. Let's open them up and see what they look like. We'll start with the high-level Finances folder. The Finances folder has been organized categorically. There are subfolders like Budget, Invoices, and Payroll that represent different categories. Let's click on Invoices to see what's in there. So in the Invoices folder, you can see that we have another set of subfolders labeled by year. 2014, 2015. Yep, looks like these are in chronological order. Sometimes the way files are organized can tell us how the data within those files is also organized. Let's open a file to see if that's right. So in the 2014 subfolder, there's a file with invoices from June. If we open it, we can see that they've been organized by date, just like the folders. There's different ways to organize data depending on what you need it for. The categorical organization of the subfolders in Finances made it easy for me to go straight to the invoices, but the chronological organization of the Invoices subfolder can help us find financial data from the exact date we're looking for. There's other ways to organize data too, in order of importance or even by location. For example, a company might use hierarchical organization so that employee data mirrors the structure of their employee organization. Or a company working with geographical data might choose to organize by location. It's a good idea to take time early on in a project to consider what the best organization methods will be for you and your team to stick to. Here's another way to think about it. Unorganized data is like a messy room. It's overwhelming, hard to find anything in, and gets worse the longer you avoid cleaning it up. But by making sure early on you know where to put your files, you can keep your work data organized, easy to use, and error-free. Now that you see how important it is to keep data organized for both personal and work use, we'll take a closer look at file naming conventions and how they carry over into your databases. See you in the next video. Hey again, so you've heard me mention the idea of using meaningful and logical file names to help organize your data. But using consistent file names can also streamline or even automate your analysis process, saving you time and energy in the long run. When used consistent guidelines that describe the content, date, or version of a file and its name, you're using file naming conventions. And as we've already discovered, these file naming conventions help us organize, access, process, and analyze our data. So here's some general tips on creating file naming conventions that are both logical and functional. Here are some quick file naming do's. Work out your conventions early to avoid having to spend time redoing it later. Align your file naming with your team. And make sure your file names are meaningful, with references to the project name, creation date, revision version, or any other useful information needed to understand what's in that file. Now there's some other simple things you can do to make sure your file naming conventions are on point. First of all, you want to keep your file names short and sweet. They're supposed to be quick reference points that tell you what's in a file. From earlier videos, we know that we want to include dates and revision numbers in our file names. I recommend formatting it by year, month, and day because that follows the International Date Standard. Different countries have different date conventions, so keep that in mind. And when you include revision numbers in a file name, lead with a 0 so that if you run into double digits of revisions, it's already built into your conventions. And another good rule is to use hyphens, underscores, or capitalized letters instead of using spaces. Spaces and special characters might not be recognized by your software. Plus, avoiding spaces definitely makes it easier to work in SQL. And my last bit of advice, create a text file that lays out all your naming conventions on a project. This is really helpful if someone new joins your team, or if you just need a quick reminder while you're working on something. We talked about this earlier when we covered metadata, which is data about data. It helps explain what data there is and how it's being organized. When you use consistent, meaningful file naming conventions throughout your project, your data will be easy to find and use, and you can save yourself time too. Up next, we'll keep looking at spreadsheets, and we'll talk about security features and how you can use them to protect your data now that it's organized. See you there. You're back. Okay, now that our data is organized and easy to find, it's time to start thinking about how to protect it. The good news is that spreadsheets come with security features already built in. In this video, we'll look at different spreadsheet programs and how their security features, like sheet protections and access control, are similar. When I say security features, you might be imagining ways to protect data from other people. But that's just one kind of security. Security features can be designed to keep unauthorized users from viewing certain files or just lock your worksheets so that you don't accidentally break your formulas. This is called data security. Data security means protecting data from unauthorized access or corruption by adopting safety measures. Whatever spreadsheet program you're using will have similar security measures built in. As a data analyst, you'll run into Google Sheets and Excel a lot. So let's talk about what they have in common. First, both programs have features that let you protect your spreadsheets or parts of your spreadsheets from being edited, from the entire worksheet down to single cells in a table. So if you're collaborating with other users, you can easily lock down your formulas so that they aren't accidentally broken. Speaking of collaborating, Excel and Google Sheets both have access control features like password protection and user permissions. This gives you more control over who can do what to your spreadsheet. Because these programs are located in different places, these features are slightly different. For Excel spreadsheets, you can encrypt files and worksheets with passwords before emailing them to other users. In Google Sheets, these settings are found under the Sharing menu, which allows you to control who can see or edit the sheet online. Google Sheets can also be copied so that users can work with that data without altering the original. Tabs can also be hidden and unhidden in Sheets and Excel, allowing you to change what data is being viewed. But remember, even hidden tabs can be unhidden by someone else, so be sure you're okay with those tabs still being accessible. As a data analyst, data security will be a priority. But no matter which program you use to create spreadsheets, there's security features to help you keep your work safe and secure. There are some other basic best practices you can take to keep your data more secure overall, which we'll cover later in a reading. You've made it to the end of this module. Congrats! In these videos, we've covered strategies for organizing data for personal and work use, how to develop functional file naming conventions, and some security measures you can take advantage of in spreadsheets. Before you move on to the next step in the data analysis lifecycle, it's important that you make sure your data is prepared, and that includes organizing and securing it. As usual, after this video, you'll have your weekly challenge. I know you've got this. Then, after the weekly challenge, there's some optional material all about connecting to the online data community. As you start building your career in data analytics, it'll be really valuable to connect with others, learn about new trends in the field, and share your own work. I think you'll get a lot out of those videos. They'll help you develop a professional online presence and find ways to communicate with people in your field, which is key as networking becomes more and more online and remote work opportunities become the norm. But if you feel pretty confident about your online presence, you can move into the course challenge instead. Good luck on this weekly challenge, and I'll see you soon. Hey, it's great to have you back. So far, we've covered everything from using SQL to the key aspects of data ethics. You've developed a huge range of skills, and they're all going to help you on your journey to a career in data analytics. But you don't have to do everything on your own. As a data analyst, you'll be part of a growing data community. By building a consistent and professional online presence, you'll be able to connect to others in your field and expand your network. Coming up, you'll learn how you can get started building your online presence, or if you're already part of the community, how you can take your online network even further. With remote online work becoming more and more common, so is online networking. That means having and maintaining a well-developed online presence could open the door to so many new opportunities. I find myself reaching out to people I've worked with throughout my career to stay in touch, ask them questions about their experiences, and just see what interesting things they're doing. And that's only possible because I keep up my online presence. Join me in the next video to get started building your online presence and get connected. Hey again, today a lot of us spend a lot of time connecting with people online. We stay in touch with family and friends we can't see every day, or post about what we're doing, eating, and watching on social media. But our presence online goes beyond the personal. A consistent and professional online presence is an important tool in building a career in data analytics. A professional online presence is important for a few key reasons. First, it can help potential employers find you. Second, it lets you make connections with other data analysts in your field, learn and share data findings, and maybe even participate in community events. Keep in mind that a lot of networking happens online now, so if you aren't keeping up your online presence, you might be missing out on great opportunities without even knowing it. There are lots of different professional sites that you can take advantage of as you start building your own online presence. For now, though, we'll focus on LinkedIn and GitHub. LinkedIn is specifically designed to help people make connections with other people in their field. It's a great way to follow trends in your industry, learn from industry leaders, and stay engaged with wider professional community. And if you're actively looking for a new job, LinkedIn has job boards that you can search. You can even narrow down your location to see who's hiring near you. Plus, job recruiters frequently use LinkedIn to find potential data analysts for new projects. So it's always a good idea to keep your LinkedIn profile up to date with your resume. You might find yourself being recruited. LinkedIn also lets you connect with people and build a network. You can share exciting things happening in your professional life and keep up with where your connections go. You never know when you might end up working with someone again. With LinkedIn, you can be endorsed for having job skills or endorse other people. So if you impress someone at a previous job, they could let other people know just how awesome you were to work with. GitHub, the other website I mentioned earlier, is a little different. GitHub is part code sharing site, part social media. It has an active community collaborating and sharing insights to build resources. You can talk with other GitHub users on the forum, use the community-driven wikis, or even use it to manage team projects. GitHub also hosts community events where you can meet other people in the field and learn some new things. GitHub has a lot of features for you to check out, and the best way to learn more about it is to check it out for yourself. We'll also be talking more about GitHub later in the program. Sometimes, if you're looking for a new career, finding someone who has something in common with you, like shared interests or the same hometown, and reaching out to them can help a lot. Just a 15-minute conversation with someone could set you on the path to a new career, whether that's on a professional networking site like LinkedIn or at a community event hosted by GitHub. LinkedIn has become one of the standard professional social media sites, so it's a good starting place for building your online presence. And GitHub offers a lot of really great tools for data analysts in the community. So if you don't already have accounts on these sites, challenge yourself to set them up now. Connect with other people, share some updates about what you're working on right now. And if you're already using LinkedIn and GitHub, great news. We're going to talk more about how to enhance your existing social media presence next time. See you soon. Hello, let's talk about social media. Today, there's 3.8 billion people using social media around the world. So there's a good chance you probably already have an online presence. That's great. It means you're already connecting with people online, maybe even professionally on websites like LinkedIn. And if you aren't, getting started is as easy as signing up today. But there's some really easy ways you can enhance your online presence even more and use your existing profiles to build your professional identity. One of the first things you should ask yourself when looking at your new or existing online presence is this: would you be okay with potential employers and colleagues seeing your social media profiles? Try putting yourself in their shoes. When a potential employer is looking at your public profiles, they're asking themselves if you're the right person to represent their company and values. Is there anything on your current accounts that could make them think otherwise? If you want to limit what you share, be sure to check the privacy settings on your accounts. If they're set to public, anyone can see everything you post. You can also make specific photos or albums private, but remember, this doesn't erase them from the internet. Keep in mind, changing your privacy settings doesn't necessarily keep all of your posts secure, so you should always think carefully before you post. Now, the best way to make sure that your posts and photos are appropriate and professional is to delete any that you wouldn't want your future boss to see. And if you're getting ready to upload photos for the first time, think about how those pictures represent you before posting them. Feel free to back up these photos for your personal files, but maybe don't put them on Facebook or Instagram. Speaking of Facebook and Instagram, there's some easy options for deleting posts on these platforms. Both Facebook and Instagram have an archive function that allows you to remove posts from your profile. You can even mass delete posts on Facebook. And while you're at it, check your Twitter. Your social media profiles are probably connected, so it's important to make sure that they're all representing you the way you want to be seen professionally. A good rule of thumb, your posts should be family friendly. This goes for photos and text posts. Check to make sure your content and language is appropriate for the whole family. And while we're working on enhancing your online persona, a professional profile picture is a great touch. Even if your account is set to private, recruiters will likely still be able to see your profile picture. Having a photo for your LinkedIn profile is important because it significantly increases your chances of being contacted. So make your profile picture one that represents your professional side in the best way possible. Once you've gotten your profiles up and running, post mindfully. Think about the professional image you're trying to create and stick to it. This means curating posts for different platforms. Decide which platform you want to use for family and friends, like Facebook and Instagram, and keep updates about your personal life on those platforms. Use professional platforms like LinkedIn for posts related to your work life and building professional relationships. A huge number of companies and hiring managers use online sources to identify and pick candidates. So it's important to make sure that your online presence has a positive impact on your real life. Make sure your online presence is job appropriate by making your accounts private, deleting posts you wouldn't want your boss or colleagues to see, and posting mindfully. And don't be afraid to ask someone you respect professionally to take a look and give you some feedback. That can be a big help in building that online presence and using it to make connections within your professional community. Now that we've built and enhanced our online presence, let's learn more about building networks and reaching out to other professionals. See you soon. Which profession does the best networking? The fishing industry. But in all seriousness, the work we do has everything to do with people. So once you've learned the skills and developed a strong portfolio, the next step is to connect with people in your profession or industry who can help you use those strengths to build a career. So in this video, we're going to talk about networking. Networking can be called professional relationship building. It's all about meeting people, both on and offline, and building relationships with them. Networking will help you meet people who are similar and different from you, and also stay current with what's going on in your field. Even within the organization you're in, you want to network with other teams to better understand the projects you're working on. Here's the truth. Lots of the best opportunities aren't posted on job boards. They're out there in the real world. Problems waiting to be solved, innovations just waiting for inspiration. So building your network with other data analysts could really increase your odds of breaking into the field. Actually, networking with any industry professionals could help you do that. Here's a few things you can start with. Search for public meetups in your area. There's usually at least one in every major city. Just Google Data Analytics Meetups near you, or search on meetup.com. Then you can learn more about different types of data analytics or share your interests with other people in the field. It's also good to remember that we live in a digital world, so don't feel confined to in-person networking. Some of the best data analysis influencers are on social media. Follow interesting companies or thought leaders on LinkedIn, Twitter, Facebook, and Instagram. Interact with them and share their content. If there's a post you like, maybe leave a comment explaining why. Digital networking can take you anywhere these days. On top of that, there's also plenty of great data podcasts to follow, like Partially Derivative and the O'Reilly Data Show. Not only can they help you stay up to date with how the industry is evolving, but hearing the concepts repeated over time can help build your confidence in your own knowledge. There's also a ton of blogs and online communities, like O'Reilly, Kaggle, KD Nuggets, GitHub, and Medium that can help you connect with peers and experts. The possibilities are virtually limitless when it comes to building your network. And in our next video, we'll talk about one of the most effective methods, finding a mentor. Trust me, you don't want to miss this. It was Maya Angelou for Oprah Winfrey, Steven Spielberg for J.J. Abrams, and Warren Buffett for Bill Gates. It's a mentor, and having one can have a huge impact in your career and your life in general. Basically, a mentor is a professional who shares their knowledge, skills, and experience to help you develop and grow. About 3 out of 4 people think that having a mentor is an important part of professional development, but studies found only 37% actually have a mentor. As a data analyst, you're not required to have a mentor, but those who find a good one never forget them. Mentors come in many forms. They can be trusted advisors, sounding boards, critics, resources, or all of the above. Sometimes the relationship happens naturally, but usually you need to formally ask them to mentor you, because they might not know you're interested in their mentorship. I've tried to seek out mentors at every stage of my career, from school to my current role at Google. It's always good to make sure your mentors have the time to support your growth, and it's just as important for you to keep up a professional relationship with them. On top of a mentor, a sponsor can also help you in your career development, but we'll talk more about that a bit later. It's very important to figure out what you're looking for in a mentor. This will help narrow down your list of potential professionals. Try thinking about your strengths and challenges at work and how you'd like to grow as a data analyst, and share that openly with potential mentors. It's also great to think about shared experiences or common ground. Maybe you're a veteran who'd benefit from the guidance of a data analyst for the military, or maybe you just think you could really benefit from talking with someone from your hometown. There's no one right way to find the perfect mentor. Your mentor doesn't even have to work with you. If there's no one you can connect with in your current work environment, you can find mentors anywhere from a social media platform, networking event, or mentor matching program. For instance, websites like score.org and micromentor.org and an app called Mentorship allow you to look for specific credentials that match your needs. You can then arrange dedicated times, maybe on the platform, to meet up or talk on the phone. Personally, I like reaching out with a friendly email or message on a professional networking site. If you go this route, take some time to describe your career goals and how they might align with their own experiences. Try mentioning some things you particularly like about their work or published content. From there, you can easily suggest a coffee chat, virtual meetup, or email exchange to get things going. Once you've had a few exchanges, be sure to check in with yourself. Make sure it's a natural fit and that you're getting everything you need. It's also a good idea to check in with your mentor to make sure it's working well for them too. Remember, this is a partnership. You and your mentor are equal participants, so the more authentic and honest you are about it, the better it will go. For example, it's always a good idea to share your gratitude for their time and effort. Now, while a mentor will help you gain critical skills and navigate challenges at work, a lot of people find that having a sponsor can take their career even further. A sponsor is a professional advocate who's committed to moving a sponsee's career forward with an organization. To understand the difference between these two roles, think of it like this. A mentor helps you skill up. A sponsor helps you move up. Having the support of a sponsor is like having a safety net. They can give you the confidence to take risks at work, like asking for a new assignment or a promotion. So let's talk about how you get a sponsor. Well, unlike mentors, you don't get to choose the sponsor. The sponsor almost always chooses you. So the best course of action is to commit yourself to doing your best work at all times. And there's a good chance someone with influence will take notice. Now that we've seen the importance of networking and relationships, it's a good idea to take some proactive steps. First, build and nurture your LinkedIn presence. Next, look at your current social media presence and make sure it's helping you put your best foot forward. Finally, always be open to connecting with peers and colleagues. You never know what great things a conversation will bring.
Hi, my name is Rachel, and I'm the Business Systems and Analytics Lead at Verily. I've been lucky enough to have some really great mentors over the course of my career, and I cannot emphasize enough how important it is to have someone in your corner as you're navigating all of the different ins and outs of your career. For me, I've had some wonderful mentors who have guided me through some really tough career decisions, starting way back at the very beginning. My first mentor was a professor at school, and this professor gave me wonderful advice of how to follow my dreams and how to lean into what I was interested in. I think it's very important to also have great mentors at work. My mentor helps me navigate all the ins and outs of my organization, all the ins and outs of the politics sometimes, and also helps me make decisions on what to do next. And so it's nice to have a mentor who's outside of what's going on, but it's also really nice to sometimes have a mentor who understands the environment. I catch up with my mentor regularly, just to touch base, just to see how we're doing, to maintain a relationship. But I specifically will schedule time with my mentor when I'm wrestling with some sort of tough question or when I have a pivotal moment coming up. For example, I've had some great conversations with my mentor about whether I really lean in on the finance side of my career or whether I want to lean in on the IT side and the system side, and helping make some of those decisions about where to focus and what to take some classes in, what to continue education on, and where to lean in with upcoming projects. Talking that through with somebody has really helped me make sense of some jumbled thoughts and figure out where to go next. I think the most important thing to look for in a mentor is somebody who you will get along with and somebody that you trust. This is a person that you're going to go to with some of potentially the toughest choices of your career, looking to them for guidance and for help and for support. my most successful mentors, the most successful mentoring relationships that I've had have been with people who I'm close to, personally or professionally, and who I trust and who I feel comfortable sharing potentially deep thoughts with, and a lot of potentially sensitive details about what I'm thinking, what I'm going through, and what I want, to help so that they can help me make sense of that and figure out what to do. And I love now that I can pay that forward and share some of the wisdom that I've learned from my mentors and from some of the experiences that I've had in my career, and help share that with someone else so that they can navigate some of their same decisions and some of those same situations, and hopefully learn from some of my experiences and some of my mistakes. And helping pay that forward is what's really exciting about being a mentor.
Welcome back. Before we get started, let's take a moment to celebrate how far you've come and everything you've learned in this course. You're almost halfway through this program. Thanks for sticking with it. So far, you've learned about data types and data structures and discovered the importance of bias and credibility in data preparation and analysis. We also explored databases, different ways to organize and protect your data, and even how to join the data analytics community. All of this will help you prepare your data for the next step in the data analysis lifecycle: processing. Processing your data to make sure that it's clean and complete is the last step you take before you start analyzing it. And that's exactly what the next course is all about. I'm excited to reintroduce fellow Googler Sally, Performance Measurement and Analytical Lead. She's going to be your guide throughout this next course, which is all about cleaning and processing your data for analysis. Coming up, you're going to learn about integrity in data analytics, basic data cleaning skills, and data cleaning in SQL. We'll also learn how to verify and report your data cleaning results, and, if you're up for it, adding data to your resume. Before you go, let me just say one more time: fantastic job. When you're ready, you can go ahead and start the next course. Sally will be there to guide you through it.